Hi students, I hope that you all are fine. In this video, we are going to discuss about force and motion from 7th standard, unit 2. Let's see the picture students. Kavita can reach the school in 2 ways. Can you tell by choosing which path she could reach the school early? So, she select road A because it is a shortest distance. Look at these pictures students. In which path the leaf will reach the ground first? Path A only reach the leaves first because it is the shortest distance. From the above example, we conclude that the straight line path is the shortest distance between the 2 points. So, what is meant by distance? What is meant by displacement? So, distance means the total length of a path taken by an object to much one place from the other is called distance. So, what is displacement? The shortest distance from the initial to the final position of an object. Both the distance and displacement possess same unit. So the SI unit is meter. Next topic is speed. In 6th standard, we are already studied about speed in detail. Speed is equal to distance by time. What is speed? Speed is the rate of change of distance. So unit is meter per second. There are two types of speed, uniform speed and non-uniform speed. Next, velocity. Velocity is the rate of change of displacement. So velocity V is equal to displacement by time. So the SI unit of velocity is equal to meter per second. If an athlete in the diagram takes 25 seconds to complete a 200 meter sprint event, find her speed and velocity. How can we calculate the speed of the speed? So speed is equal to distance by time. So S is equal to 200 divided by 25. So the speed of the athlete is 8 meter per second. Next, velocity. Velocity is equal to displacement by time. So answer is 50 divided by 25, 2. So the velocity of athlete is 2 meter per second. Next one is uniform velocity. A body has uniform velocity. It covers equal displacement in the same direction in equal intervals of time. Example, light travels through vacuum. Next, non-uniform velocity. If either speed or direction changes, the velocity is non-uniform. Example, a train starting and moving out of the station. Okay. How can we calculate the average velocity? So, average velocity is equal to displacement, total displacement by time. Okay, so average velocity is equal to total displacement by time taken. Next one is acceleration. Acceleration is the rate of change of velocity. In words, if a body changes in speed or direction, then it is said to be accelerated. So, acceleration is equal to change in velocity divided by time. So, A is equal to V minus U divided by T. So, SI unit of acceleration is meter per second. Next one is uniform acceleration. An object undergoes uniform acceleration when the change in its velocity for every unit of time is the same. Next, non-uniform acceleration. An object undergoes non-uniform acceleration if the change in its velocity for every unit of time is not the same. Next one is center of gravity. See the diagram, students. Generally, the center of gravity of the geometrical shaped object like on the geometric center of the object. Example, center of gravity for regular shaped object, weight of card, weight of triangle, weight of disc, weight of ring. You've seen, okay? Next, meter rule. The ruler in the equilibrium when supported at the center of gravity. For a regular object such a uniform meter rule, the center of gravity is the center of the object. When an object is supported at the point, it will be balanced. If it is supported if any other points, it will be toppled. Next one is stability. Stability is a measure of the body ability to maintain its original position. So stability is divided into three: stable equilibrium, unstable equilibrium and neutral equilibrium. First one is stable equilibrium. The frustum has been tilted through quite a big angle without toppling. If the center of gravity is raised when it is displaced, the vertical line through the center of gravity still falls within its base. So it can return to its original position. Next one is unstable equilibrium. The frustum will topple with the tightening. Its center of gravity is lowered when it is displaced. The vertical line through its center of gravity falls out of its base. Next one is neutral equilibrium. It causes frustum to topple. Its center of gravity remains the same height when it is displaced. The body will stay in its any position to which it can be displaced. Next, conditions of stability. Lower its center of gravity and increase the area of its base. This box in the point tippling over. For example, Tanjavur Dal. It is a type of traditional Indian tie made of terracotta material. The center of gravity is the total weight of the doll is concentrated at its bottom most point, generating a dance-linked continuous movement with slow acceleration. Next one is real life application of center of gravity. See the picture, students. Stone is arranging in order wise. Biggest stone is at the last. Lowest stone is at the first. So, according to highest position that under the stone is present in the table, the center of gravity is 1 point. So, it is stand properly, straight properly. Okay, students. For the recent stability that the luggage compartment to a tour bus located at the bottom and not at the roof. Racing carts are built low and bored for stability. Table lamps and fans are designed with large heavy bases to make them. So see here, students, at the same like this stone also having some unity, not gravity. that is center of gravity. Okay students, I hope that you all understand. Thank you students.